Find the area of the loop of the curve y square find the area, and therefore we will find out what kind of curve is this, and hence as such this is a equation of curve, but if we want to treat it as function we will have to take square root, positive or negative, radical 1 minus x upon 1 plus x. The moment we write this as function, we come to know y is equal to 0 if x is equal to 0 or x is equal to 1, right? This is going to be a real valued function for all values of x between 1 to minus 1, because the moment this fellow becomes greater than 1, inside radical you have negative sign. It does not remain real function. Now if I want y to go to infinity, if y tends to infinity, now y tends to infinity, if we take this plus and minus sign to the other side, therefore y will tend to plus or minus infinity depending upon x tending to minus 1. Okay, so as x tends to minus 1, you will end up y tending to, so this is a basic information about the function, and you cannot take value of x less than minus 1 greater than 1. If x is equal to 0, answer is 0. So all those special things after we figure out, we should try to sketch the curve, and the curve is going to be like this. This is minus 1, which is asymptote, plus 1, beyond which x values will not be available. So if you want to sketch one of the arms, then it will go like this. It will go to minus infinity as x tends to minus 1. It goes up like this, and it, after you differentiate etc. one of the functions, you will come to know that there is a local maximum here. Tangent at 1, 0 is having infinite slope vertical line, and therefore the function is like this, and you are required to find out this area. That is the first understanding that you should have about the given curve. This is 0, this is 1. Now you can, what you can do is, it is symmetric with respect to x-axis, therefore required area is equal to 2 times integral 0 to 1. You can take positive function x radical 1 minus x upon 1 plus x dx. That is where you start solving integral. Before that, it is analysis of the curve that you have, and then your game starts. And hence I will write down all those steps very quickly. Which is equal to 2 times integral 0 to 1 plus x minus 1 radical 1 minus x upon 1 plus x dx. Then if you take 1 plus x into this, So 1 plus x into this entire thing will become 2 times integral 0 to 1 root 1 plus x into root 1 minus x, that is root 1 minus x square, that is the first part, dx minus 2 times integral 0 to 1 radical 1 plus x on 1 minus x dx. Correct? So what should we do? I think we can deal with this independently, and therefore we need to pay attention to this. Again, you are supposed to what? बरोबर लिहिले, चुकलं आहे वर खाली. 1 minus x upon 1 plus x. So if you multiply both by root 1 minus x, you get radical integral 0 to 1 minus x upon radical 1 minus x square dx minus 2 integral 0 to 1 upon radical 1 minus x square dx plus 2 integral 0 to 1 x upon radical 1 minus x square. So I think all the integrals are doable now. Integral 0 to 1 radical 1 minus x square dx. All of them are doable, and therefore the final answer is 2 inside bracket x by 2 radical 1 minus x square plus half sine inverse x minus sine inverse x minus radical 1 minus x square bracket complete 0 to 1, and if you substitute 0 and 1 you end up getting 2 inside bracket 1 minus pi by 4. Answer becomes 2 minus pi by 2. That is your final answer. Ask if you have any difficulty. Next problem. Find the whole area of the curve. A square y square is equal to a square x square minus x fourth. Again, similar kind of analysis if you do, you will come to know that the nature of this curve is like this. A comma 0 minus a comma 0 everything same. So 4 times area from 0 to a, required area is 4 times integral 0 to a, the positive root, y is equal to x by a radical a square minus x square. Okay, so that is what is the required area. Now it is your skill to deal with this. Outside there is x, so I don't know what is the shortest method, but I have a method by which you have to put x is equal to sine theta, a sine theta, which will give you at x is equal to 0, theta is going to be 0, x is equal to a, theta is going to be pi by 2, and dx is equal to a cos theta d theta. Correct? So everything if you substitute, you get a is equal to 4 integral 0 to pi by 2 a sin theta upon a, then a square comes out to be common, a radical inside radical 1 minus sine square root cos theta into a cos theta sin theta d theta. That makes it sine square cos square. I don't know. Why is this sin theta here? A cos theta d theta makes it 4 integral 0 to pi by 2 4 a square sin theta cos square theta d theta. बराबर चल रहे. So cos theta is equal to t, and therefore minus sin theta d theta is equal to dt. If theta is equal to 0, t is equal to 1, theta is equal to pi by 2, t is equal to 0. Therefore, this equation becomes minus 4 a square integral 1 to 0 t square into t. Minus sign can be absorbed, it becomes 1 to 0. Then it is 4a square t cube by 3, 4a square t cube by 3 to be evaluated between 1 to 0. If you put 0, it is 0. If you put 1, the answer becomes 4a square by 3. That is the area of whole loop. अरे समझते का? So, okay, consider a curve y is equal to f of x between point A and B, whose foot of perpendicular is a dash and foot of perpendicular is b dash, and maybe this is your x-axis. And if you revolve this particular curve around x-axis, then what will happen is you will produce a solid of revolution. It will be looking like this. After you revolve it around x-axis, you will have a solid something like this. If you revolve, of course, this area. So this integration technique can be used to find out the volume of solids generated out of revolution, one revolution. Okay. So what will be our formula for doing that? Let us try to derive it. Let me write down the same thing in the form of theorem. We will try to write down why that formula. If a function f be continuous, in the interval a comma b, and if the curve y is equal to f of x does not cross the axis, if the curve does not cross the axis, then the volume of solid of revolution about the x-axis of the area bounded by the curve y is equal to f of x, the x-axis and the ordinates x is equal to a and x is equal to b is given by v, volume v is given by integral a to b pi y square dx, which is equal to integral a to b pi f of x dx. So volume of solid generated out of revolution is given by this. Now let us try to figure out why is this. So we have, say, increasing function with us, and we consider any point here and incremental point here. Let me name those points. This point is P, this point is Q. N, M. They are perpendiculars. P dash is a foot of perpendicular on x-axis. Q dash is foot of perpendicular on y-axis. So, area of rectangle P, P dash, Q dash, M is going to be less than a required area, area under consideration, area P, P dash, Q dash, Q is less than N, P dash, Q dash, Q, this area. Of course, we are doing this by looking into the diagram. If the function is decreasing, then the signs will be, inequality signs will be different, but concept is going to remain same. Suppose this distance is incremental delta x. Coordinates of P x comma y. Coordinates of Q are going to be x plus del x comma y plus del y. Is that correct? Increment is of. So now if we write down these areas, then how much will be p dash q dash m? P dash q dash m is a cylinder. Therefore, pi radius is p dash, which is y square, and the height is del x, is going to be less than, let us call this volume. I mean, this is area calculation, but now we are revolving that area so that it is a cylinder, and therefore we are calculating the volume now. The volume of this, let us say that volume is dV, change in volume, is going to be less than pi into y plus del y bracket square del x. Okay. Now if we dividing pi y square del x by del x is less than del v by del x is less than pi y plus del y bracket square into del x by del x, right? So I mean, this is easy. I'm just making it technically correct. Now taking limit, this is, I mean, we are going to use the sandwich theorem. Function wise we have said that this is smaller, this is middle, and this is the upper function, and by taking limit as del x tends to 0, pi y square should be less than limit del x tends to 0, del v by del x is less than limit del x tends to 0, pi into y plus del y bracket square. Correct? And hence this limit will tend to pi y square, because this is pi y square, this is pi y square, therefore this limit must be y square, and hence that, I mean, this limit is dv by dx is equal to this, and therefore v is equal to integral pi y square dx between the limits, of course, at this is the incremental volume that we have found out, and now we want to do it from a to b. That is where this continuous function is defined, and therefore we end up getting this formula for volume. I mean, it is easy, not very difficult. Just write down whatever you have understood, and if you have not understood something, you ask me. Okay. So this integration technique can be used for finding out volumes of the solids which are symmetric. I mean, we can visualize them as volume of solid of revolution, and we can definitely find out. So first amongst them is most important volume of sphere. Because volume of sphere geometrically is a difficult job. It's a lengthy procedure. We get it, not that we don't get, but so your setup is like this: x-axis, y-axis, radius of the sphere is a, so you are here minus a, and and here is also A. So you have a semicircle with you. This is the area of semicircle which will revolve around x-axis, and check whether you get 4 by 3 pi a cube. Find volume of sphere with radius A. Very simple. Okay, so volume of sphere answer comes out to be 4 pi a cube by 3, and it is very simple. And you remember the proof that we did for volume of sphere geometrically, Cavaliere's principle, etc. We'll have to go round and round. However, if you have advanced tool of definite integral, you can do the job very quickly. That is the moral of the story. Better tool, more efficient. Second problem. Definition. Frustum of a sphere is a portion of sphere included between two parallel planes. So now we are supposed to find out. We have a sphere and we are supposed to find the area between A to B. We are interested in this area of revolution. Okay, and this is A, this is B, and radius of the sphere is R. Find volume of frustum of sphere between A to B. Radius of sphere is R. It is given. Tell me what is the formula. This radical is not correct. We don't want y, we want y square. कोणी काय बोलत नाही, सगळे शांत आहे. Okay, the answer is pi by 3 b minus a 3r square minus a square minus b square minus ab. Okay, next question is find the volume of spherical cap of height h of a sphere with radius smaller. So, what is spherical cap? Portion of the sphere cut off by a plane. सांग, दाखवा आन्सर, त्याशिवाय तुम्ही चुस्त राहणार नाही. Okay, the answer for this is pi by 3 h square 3r minus h. Let me know if you cannot solve it. I will help. Then find the volume of cone with height h and radius to r. Now, using definite integral, we are trying to do these calculations and get these volumes. However, calculus has 300 years history. People have found out these volumes, these areas, this volume of sphere, cone, etc. much before that using pure geometry. But now, because we have a better tool, we can do it very quickly. So we are just verifying our tool whether it gives us the same old answers or not. That is the job we are doing. So find out volume of cone. Setup should be like this. Some slope r upon h is your slope into x. Y is equal to r upon h into x. If you integrate, you will get this answer. Next is find the volume of frustum of cone. Whose height is width, height equal to h, with height equal to h, and radius of small circle, small face r1 and bigger face is equal to r2. So you have a spheric frustum of cone, something like this. This is r1, this is h, and this is r2. Find out. Again, similar calculation, similar setup. Answer is pi h by 3 r1 square plus r2 square plus r1 r2. Okay. Next. A straight line two x minus 3y plus 8 is equal to 0 cuts the parabola. Y square is equal to 8x in A and B. Find volume of solid. Generated by revolving. The area enclosed between the parabola and chord AB. About x-axis. The area is going to be looking like this. First of all, you have a parabola, and then you have a chord 2x minus 3y plus 8, something like this, not to scale. So if you solve them simultaneously, you will get to know the x coordinates 2 and 8, corresponding y coordinates 4 and 8. Okay, so this area is supposed to be, so first volume is volume 1, that is outer, y square. So integral 2 to 8 pi into 8 into x. This will be dx. This will be 240 pi. Volume 2 is integral 2 to 8 pi into your y is 2x plus 8 by 3 square. This will be 224 pi. Therefore, required volume V is equal to V1 minus V2 is equal to 16 pi. Next problem. The area in the first quadrant between the curve one plus x square is equal to 1 upon y and the coordinate axis. Axis is revolved about x-axis. Find the volume generated. Limits in this case, because it is given that the area in the first quadrant is to be considered for revolution. So limits comes out to be 0 to infinity. Okay. So the required volume V is equal to 0 to infinity pi y square dx is equal to integral 0 to infinity dx upon pi goes outside dx upon 1 plus x square bracket square, correct, which you should solve by putting x is equal to tan x tan theta and do the required calculations. You will get the integral and evaluation of that. Eventually the answer will be pi square by 4. That is how it is going to be. So finally it boils down to whether you can solve the given integral or not. This is application of definite integral that we are doing. Maybe a couple of more problems today on this. Find the area of the loop. Green अजिबात वापरला नाही. Find of the curve 9y square is equal to x minus 2 into x minus 5 bracket square. Also find the volume of revolution of the loop about x-axis. Tada. First answer, area of the loop is 8 root 3 by 5 and volume of revolution of the loop is 3 pi by 4. Okay, that is what it is. Do you want me to write down equation? I mean, it is simple. It is, you are supposed to, while finding out area, you are supposed to use y. While finding out volume, you are supposed to use pi y square for integration. And you will get the answer.